Welcome back to the second lecture. Today we will be finishing section 1.1, right? But before we start with today's lecture, I want to go over finding LCD. I don't know where my brain was on Monday, but the way I explained it, it was not correct. And even while I was explaining it, I was kind of iffy. So let me explain. My brain was still on vacation, apparently. So when you're finding the LCD, you're looking at every, let's just say like this was plus equals, right? No commas, right? And then you want to solve for this, but you want to find the LCD first. The way you do it is you take each denominator, so I have 3, 4, and 6, right? And the way I do it is you do the prime factorization. A prime factorization, so every number can be rewritten in primes, right? With primes only. So 3 is just 3. 4 is 2 times 2, okay? But this is also 2 squared, right? And then 6 is 2 times 3, right? So now what you do, okay, so disregard what I said yesterday. You look at all these factorizations and you just pick each unique number. So I see 2 and I see 3. Right? Now that they're listed, what you're going to do is you look at each number that you listed and you want to take the highest exponent. Right? So for the 2, as you can see, I have 2 to the first and I have 2 squared. Right? 2 is greater than 1, so this becomes 2 squared. Right? And then 3, they're both 3 to the first, so this is just 3 to the first. Right? So therefore 2 squared, that's 4. 3 to the first is 1. 3 to the first is 3. And so 4 times 3 is 12. And that's how we got the LCD to be 12. Right? Another, just a little quick example. Say that I wanted, I don't know, maybe 1/3, 36, and 1/12. Right? If you look at this, so if you are comfortable finding the LCD and you see that it's 36, that's perfectly fine, but this is for people who need more practice, right? But before we continue on here with the LCD, when you solve equations, you don't necessarily need the LCD. You just need a common denominator. The least common denominator just helps you deal with smaller numbers and you wouldn't have to simplify as much, right? But yeah, so that's why we find the LCD. So what I'm going to do here is so what if I just do it like this, right? And I want to solve for it, and I want to find the LCD first, right? So I'm going to list off. Usually when I list them, I like to go least to greatest. It doesn't matter what order you do, right? So 3 is a prime number, so this is just 3. For 12, so if you want to do this over here to the side, 12 can be rewritten as 4 times 3, and 4 can be rewritten as 2 times 2, right? I'll show you that you'll still get the same answer as if you did 12, and let's say you said 2 and 6, right? And then 6 is 2 and 3, right? So as you can see, there's still 2 2s and 1 3, right? So this is 2 times 2 times 3, which is 2 squared times 3. Right, for 36, I'm gonna erase this. Right, for 36, I know that can be rewritten as 6 times 6. This is 2 and 3. This is 2 and 3. Right, they're both prime. So that means it's 2 times 2 times 3, times 3. This is 2 squared times 3 squared. Right, now what I'm going to do is I'm going to take each unique number. So I see 2 and 3, right? By the way, it's not always going to be like that. Sometimes there might be a 5 or a 7, right? It's just the numbers I picked. It just happened to be 2 and 3 again. Right, now I'm going to look at each 2. So I have a 2 squared here and I have a 2 squared here, right? They both match. So the highest power for the 2 is 2. And then for 3, I have 3 to the first, 3 to the first, and 3 squared. Right? 3 squared is the biggest, so I'm going to write this as 3 squared. So therefore, the LCD is equal to 2 squared, which is 4, and 3 squared, which is 9, and that makes 36. Right? And that's how you find the LCD. So now, let's change gears a little bit and let's talk about section 1.1.3, which is solving rational equations. So what is a rational equation? It's an equation where each term contains a rational expression. So, so for example, we have x over 2 is equal to 2x over 3 minus 1. So this is called a linear equation with constants in the denominator, right? How is this linear? Okay, remember what is a linear equation? A linear equation is when you can write it in the form, if you can rearrange it and look like the form ax plus b is equal to 0. So x over 2, I can rewrite that as 1/2 x. And then 2x over 3, that can be rewritten as 2/3 x minus 1. Right? So, so if we subtract this 1/2 x, right, then we'll get 0. And then so 2/3 minus 1/2, when we subtract or add, we have to have a common denominator, which is 6. So I'm going to multiply 2/3 by 2 over 2, and then 1/2 by 3 over 3. Right, so this is 4/6 minus 3/6. Right, so therefore I get 1/6 x minus 1. Right, so as you can see, A is 1/6 and B is -1. Right, so this is a linear equation. For number 2, we have 12 over x is equal to 6 over 2x plus 3. So this is called a rational equation with variables in the denominator. This, number 2, is not linear. Why? Because, so for 12 over x, right, what does it mean to be linear? Linear means that x has to have the exponent of 1. This by itself, over here, when I rewrite this, this is 12x to the -1. This is not, so these are not linear, right? This is just considered a rational equation, right? So what is our conclusion? These two examples show that all linear equations are rational equations. However, not all rational equations are linear. Right? And I'll just let you guys think about that, and if you still have questions on Wednesday, we can talk about it. So, let's go do examples. And then one thing I want to note is that when we solve rational equations, it's similar to solving linear equations with fractions. However, we have to restrict the domain of x so that we do not divide by 0. Right? And I'll get more into that in a little bit. So I'm actually going to switch these up a little bit. I'm going to do this second one first, solving a rational equation that simplifies to linear. I think it's just going to be a little more simple. So let's start with that. So for the first example, I have 9 is equal to 6 over x. Right? So first, okay, so this would be the new step 1. Step 1, step 1. So find when x is equal to 0. Okay? So find what values are restricted. Okay? So when I look at this, I have 9 over 1 and I have 6 over x. So what we do is we get our denominator, which is just x, and we set that equal to us. Not find when x is equal to 0, sorry. Find when the denominator is equal to 0. Right? In this case, our denominator is just x. So if I just set that to 0, that means our restricted value, x cannot equal 0. Right? And then so we will use that to check our final answer. And if we get an answer that is 0, that means there's no solution because that makes our equation 0 or undefined. Right? So we have 9 is equal to 6 over x. Right? So when we solve for x, okay, remember our goal is to have the coefficient to equal 1 and the exponent to equal 1. So we just want it to look like this. Okay, because this is also as x. Right? But however, it's over on the bottom. And remember, when this is on the bottom, this is equal to 6x to the negative 1. Right? So how do we get x in the numerator? Okay, I'm going to rewrite this so I don't have to deal with all of that. What I'm going to do is I'm going to multiply. I'm going to use the multiplication property or equality property, and I'm going to multiply both sides by x. Right? When I do that, I get 9x is equal to, and then 6x over x, so these x's cancel, so then I'm left with a 6. Right? So now our x has an exponent of 1, so things are going really well so far. And now all I need is for the coefficient to be 1, and right now it's 9. So what am I going to do? I'm going to divide by 9 on both sides, or we can multiply both sides by 1/9. And when we do that, we get x is equal to 6 over 9. Right, 6 over 9, they're both divisible by 3, so it can be reduced. So I get x is equal to 2/3. Right, so before you go on to that step 4 where you plug in your x to see if it satisfies the equation, what you're going to do now is you're going to compare values from step 1. We said that x cannot equal 0. So we got to compare. Is 0 and 2/3, are they the same? No, they're not. Right? So therefore, this so far is valid. So now you're going to have to check to see if it satisfies the equation. For time purposes, I will not do that. I'll let you guys do that on your own. But as you can see on my notes, it says that x is equal to 2/3. So this is correct. Right? Now for example 2, okay, we're just going to take it a step further. Instead of having x, we have x plus 3, and it's in 2 places. So what we're still going to do is I'm going to take this denominator, and I'm going to set it equal to 0. Right? And then what do I get? I get x is equal to -3. So what does that mean? Restricted value, RV, restricted value, x cannot equal -3. Right? So now let's solve for x. Okay, the first step, we want to simplify both sides. Right? I see fractions. Fractions are gross. Let's get rid of them. So let's multiply both sides by x plus 3. And make sure when you write x plus 3, you put parentheses in here. Okay? Because when you say, for example, I don't know, just this big box or whatever, and you want to multiply by x plus 3. If you write it like this, you're telling me that you're just multiplying x by whatever's in these parentheses and you're adding 3. Right? That's not the case. This is a group, right? They're together. So, parentheses. Right? So I'm going to take x plus 3 and I'm going to distribute. When I do that, we get 5x minus 6x plus 3. Right? And I multiply 2x over x plus 3 times x plus 3. X plus 3's cancel, then I get 2x. Right? I am not left with any more fractions, so I did what I wanted to do. So that's a good sign. Right, and let's continue. So remember, what is our goal? Our goal is to solve for the variable x. As you can see, there's a lot of x's in a lot of places, but it's okay. Just take it a step at a time. Before I move things around, I notice I have parentheses and a constant in front. So I got to use the distributive property. So I'm going to take this -6, right, and we're going to distribute it. When I do that, -6 times x is -6x. -6 times +3, that is -18, is equal to 2x. Okay. Before we move things again, I want to simplify, combine like terms. 5x minus 6x, that's -x. This is -18, is equal to 2x. Right? You could subtract 2x from both sides and then add 18 to both sides, but that is more work than you need to do because you can just simply add x to both sides, right? So you can make it one step instead of two steps, right? So when I add x to both sides, this will become 0x, so I'm left with -18, and then 2x plus x, that is 3x. Right, we're so close. We got x kind of isolated, all right? But our goal now, we want to make the coefficient 1. So what are we going to do? We're going to divide 3 from both sides. And when I do that, -18 divided by 3 is -6. 3x divided by 3, that is x, all right? So we get x is equal to -6. Before we plug it into our equation to make sure that the equation is that the equation holds, I want to check, is this the restricted value? The restricted value is -3. We got -6. They are not the same. Therefore, this is still a potential solution, right? Again, for time-wise, I'm not going to plug it in, right? Because I think you guys are capable of doing that yourself. But as you can look for my notes, it does say x is equal to -6. So this is correct. Now, let's talk about proportions. So proportions, they're just rational equations. All right? So, let's go ahead and solve this. So first things first, we have to determine when our denominators are 0. So unlike above, from the second start, we only had to worry about one type of denominator. All right, over here, as you can see, we have two different types of denominators. So what does that mean? That just means that we got to solve when both these denominators are 0, and most likely we will have two restricted values. Right? Sometimes the reason why I said possible, because there are times where the denominators are like equivalent, just rewritten differently, and so when you solve for it, you still get the same value, right? So when you see different ones, you just will get at most. So I'm going to take this x minus 4, I'm going to set it equal to 0. When I solve for x, I get x is equal to 4, and then for the other one, I have x is equal to 0, done, right? So what are my restricted values? My restricted values are when x is equal to 0 and 4. So now that we know the restricted values, we may solve for this. Right? Many of you are familiar when you see proportions that you can just do this x thing, right? That's fine. You can do that, but I want to kind of just explain it more. So the reason why we can do the x is because, for example, let's get rid of this x minus 4 first. Okay? When you do that, okay, you just distribute it to both and make sure you have the equal sign. When you do that, you get 15 is equal to 9x minus 4 over x. Right? And over here, to get rid of the x, you'll multiply by x. Right? Oh, meant to go over here. So this becomes 15x is equal to 9x minus 4. And as you can see, when you do the cross, you'll get 15x is equal to 9x minus 4. All right. One other way I want to show you guys is if you don't want to stray far from the steps that I've given you, if you want to still solve as if you're like solving for a linear equation, like using the steps of the linear equation. All right, so remember, rational equations, solving for that is similar, just a couple extra steps. What we'll do is, in order to get rid of this, we'll find the LCD. Okay, in this case, the LCD, I have x minus 4 and I have x. They're both to the power, when we look at this, power of 1. Right, so our LCD is just x minus 4. Okay, so what am I going to do with my LCD? I'm going to, going to take my equation, right, so we'll do x minus 4, x minus 4. Right, if you want, you can put brackets here. It's not necessary because they're multiplying, so I know they're one term. Just make sure you put parentheses around the x minus 4. Okay, because this is not x minus 4. This is not the same as x times x minus 4. Right? Not the same. Actually, let me just delete that. Okay, so when I solve for this, okay, the x minus 4s, they'll cancel, so I'm left with 15x. And over here, the x's cancel, so then I'm left with 9x minus 4. Right? So I've shown you guys 3 different ways. Pick whichever way you that makes the most sense to you. Right? But we have to remember, what is our goal here? Our goal is to solve for the variable, which is x. Right? So I see an x here, I see an x here, but this one is trapped in a parentheses. So, and there's a coefficient in the front. So what am I going to do? I'm going to use the distributive property. When I do that, I get 15x is equal to 9x minus 36. Okay, I'm going to subtract 9x from both sides, so I'm left with 6x. And then 9x minus 9x is 0x, and then negative 36. Right, now we're so close, we just need a coefficient of 1. So what I'm going to do is I'm going to divide both sides by 6. When I do that, I get x is equal to negative 6. Right, because negative 36 divided by 6 is 6. Again, we have to check, is negative 6 a restricted value? Our restricted values are when x is 0 and 4. Right, 0 and 4, none of them equal 6, so therefore this is still a potential solution. And then when you plug it back in, right, seeing from my notes, you'll see x is equal to negative 6 is a solution, or is the solution. All right, so that is it for section 1.1.3. As you can see, I have a couple of class problems. You can take a look at it before class on Wednesday, and then we will talk about them and work on them together. But now, on to section 1.1.4, which is solving literal equations for a specified variable. Right, so essentially, there's no notes for this one. All you got to do is solve for the variable they ask you to. So let's just go ahead and get started. We're given d is equal to rt, and I hope that looks familiar to you because this is called the distance formula. Distance is equal to rate times time. We will talk about that later. Right, but as of right now, this is just an equation, and we want to solve for r, right? So we've just been dealing with numbers lately, and usually it's a lot easier for people, but now we're getting a little more abstract, right? But nothing is different. Okay, so what does this mean? This means that our goal is to get r by itself. And I'm sorry, I know my r's kind of look like v's, right? But we want to get this r by itself. So if this r is attached to a t, just think that t is a coefficient. You can think about it like, imagine like it's 3 or something. If it was 3, what do? You divide both sides by 3. So since it's t, and I want to get r by itself, what do? I'm just going to divide both sides by t. When I do that, I get r is equal to d over t. Right? So now, let's take it a step further, and let's solve 2x minus 4y is equal to 6, and this time we're going to solve for y. So the biggest thing I want to emphasize for this section, make sure you know what variable you're solving for. Lately, we've been solving for x, so I can see that as being a mistake. So just as long as you know how to read directions, we'll be a-okay. So we want to solve for y. So this is our goal right there. So everything else is treated as a constant. So how am I going to get y by itself? Right, what you can do is we can subtract 2x from both sides. 2x minus 2x, that's 0x. Then I'm left with negative 4y. Right, and then 6 minus 2x. Right, I cannot combine these because they're not like terms. Right, remember when we solve for a variable, our goal is to make the number in front of it, which is the coefficient, 1. So in this case, how do I make this 1? We're going to divide both sides by negative 4. Right, when I do that, I get y is equal to 6 minus 2x over negative 4. Right, but we want to simplify this. So what do? If you look at it, 6, 2, 2x and 4, they all have a 2 in common. Right, I'm gonna bring my work over here so it doesn't get smushed. Right, so, and I'm gonna bring this negative to the top, but make sure, be careful because this is considered a group. Right, so this is gonna be negative, and then I'm gonna take a 2 out, so this becomes 3 minus okay. This might be a little confusing. Okay, I'm going to keep the negative in the 4. Right, we're just going to focus on factoring, or factoring out the 2 first. So let's take out the 2. Let's do 3 minus x over negative 4. Right, this becomes a 1. This becomes a 2. So then I'm left with y is equal to 3 minus x over negative 2. Right, I personally do not like it when negatives are in the denominator, so I'm going to bring this up. Okay, when I do that, keep in mind, like I said before, this is a group. So this becomes negative 3 minus x over 2. Right, but what the hey, let's distribute this. And when we distribute it, pretty much we're just going to flip it because this becomes negative 3 plus x. I'm going to write this as x minus 3 over 2. Right, and that's your answer. These two are also acceptable, right? But just, this is my personal preference. I don't like negatives in the denominator. And when I see something like this, sometimes it looks more simplified when you distribute it. Right? You just kind of have to use your own judgment. Right? So that is example 2. Okay, so now the next little topic we're talking about, we're still going to solve for a variable, but this time we're just going to take it a step further. This time the variables that we want to solve for are going to be in parentheses. Right? But same exact process. So for example 1, we have this equation, r is equal to x minus the quantity x minus 4 times m, and our goal is to solve for x. Right? So our goal is to get this by itself. So what do we do first? I notice some people might say distribute the m. Right? You're not wrong, but how about let's take it kind of like just less work. Okay, since this is a whole group, okay, you can imagine it, say it's just like a box, right? A box times m, right? We want to get this box by itself. So what are we going to do? We're going to divide both sides by m. And when we do that, we get r over m, and then this is equal to x minus 4. Okay, why did I drop my parentheses? Because when you do this, right, so this is kind of the side. So when I do x minus 4 times m over m, these cancel. So then I'm left with x minus 4. The reason why I'm able to drop the parentheses is because the coefficient attached to this parentheses is 1, right? So essentially, we're quote-unquote I distribute this when I get rid of the parentheses. But what is 1 times anything? It is itself. So when I distribute 1 times x, this becomes x. 1 times -4, that's -4, right? So that's why we're able to drop parentheses. So we're so close. Remember what our goal is? Our goal is to solve for x. How do I do that? It's attached to this -4, so I'm just going to add 4 to both sides. And when I do that, I get r over m plus 4 is equal to x, right? And if you want, you can rewrite this as saying r over m plus 4, right? Okay. The last example I want to do today, okay, we are given A is equal to 1/2 h times the quantity big B plus little b. And our goal is to solve for little b, right? So right here. So again, just like above, okay, we could distribute this 1/2 h over, but why do that? Okay, this is just multiplied, so we can just treat this as one big blob and get rid of this, right? So we want to get rid of the reciprocal, so to make this 1, right? So what am I going to do? Okay, so let me rewrite this, and then so it'll be easier for you guys to see. When I have 1/2 h, this is also the same as saying 1/2 times h over 1. So this is h over 2, right? This is h over 2 times big B plus little b, right? So now this will be easier to see when I tell you. So what do I multiply? I'm going to multiply both sides by 2 over h. Okay, because h over 2 times 2 over h, that's 2h over 2h, that's 1. Right, so that gets rid of that. So then I'm left with 2a over h is equal to big B plus little b. Again, I dropped my parentheses because of this situation right here. We have a coefficient of 1, so I can just, when I distribute it, it's the same exact thing. Right? So again, which b are we solving for? We're solving for little b. Right? So how do I get little b by itself? I just got to subtract big B from both sides. And when I do that, I get 2a over h minus big B is equal to little b. Again, if you want, we can always put what we're solving for on the left first, and we get 2a over h minus b, or big B. Right? So that is it for today. Again, there's more class problems that we will be talking about on Wednesday, right? So yeah, so if you guys have any questions about these lecture notes, feel free to ask, and I will see you all on Wednesday. Bye!